Hello friends, myself Rajendra Mahajan, presenting my video on eigenvalues of matrix. Let us solve the problem. Find eigenvalues of matrix A is equals to, that matrix A is with the elements 1, 3, 1, 2 and 4 and 3. Once again I will repeat 1, 2, 4, 3. These are the elements. Then to solve it, characteristic equation is given by, first of all we have to find the characteristic equation, and it is given by determinant of E minus lambda I is equals to 0, where A is that matrix, given matrix, square matrix, lambda is any scalar quantity, and I is the identity matrix of the same order of E. And shortcut method, that is, it is nothing but lambda square minus S1 lambda plus determinant of A is equals to 0, terms alternately positive negative, where S1 is nothing but sum of the principal diagonal elements from left to right, A11 plus A22. And for this particular example, A11 is 1, A22 is 3, therefore 1 plus 3 we get 4. Then determinant of A, nothing but determinant of that matrix 1, 2, 4, 3. And then evaluating as usual, 1 into 3 we get 3, minus 4 to the 8. 3 minus 8 we get minus 5. And we substitute these two values in equation 1. Therefore we get, put it in equation 1, we get lambda square minus 4 lambda minus 5 equals to 0, equation number 2. And this equation 2 is called as the characteristic equation. This is the first step whenever we require to find eigenvalues or the characteristic roots. It is a quadratic equation. Finding the factors of that equation, we get lambda minus 5 and lambda plus 1 is equals to 0. Equating each to 0, we get lambda minus 5 equal to 0 and lambda plus 1 equals to 0. From first we get the value of lambda as 5, and from second we get the value of lambda as minus 1. Therefore these are the eigenvalues. Lambda is equals to 5 and lambda equals to minus 1 are the eigenvalues, or also called as characteristic roots of that matrix A. Then whatever the values obtained is correct or not, that we can cross check by the properties of eigenvalues. The first property, sum of the eigenvalues is always equals to sum of the principal diagonal element. Sum of the principal diagonal element, diagonal from left to right. And therefore we check this property. 5 and minus 1, these are the two eigenvalues. Sum of that 2 is 4. And on the right hand side we have sum of the diagonal element 1 and 3. Therefore 1 plus 3 we get 4, means 4 is equals to 4. First property is satisfied. Then another property, the value of determinant of A, and it must be equals to the value of product of eigenvalues. Here the determinant value is minus 5, left hand side value is minus 5, and the product of that eigenvalues 5 and minus 1 is minus 5. Again satisfied, and therefore please like my video, share it, as well as subscribe to my channel and press the bell icon to receive the notification. Thank you. Thanks for watching.